Hello guys, welcome back to our new video. In this video, we are going to do a chapter number 8, Laws of Motion of Science Physics. Okay, so in this chapter, we are going to cover topics like force, balanced force, unbalanced force, inertia, first law, second law, third law, and with its exercise. But in this video, this is the part 1 of this video, and part 2 I will be upload in a one day. Okay, so in this video we are going to cover topics of force, balanced force, unbalanced force, inertia, first law and second law with it derivation okay, and the third law and its exercise we will do in second part. Okay, so let's move with our part 1 and start with force, balance and unbalanced force. Okay, so let's do it. Hello guys, we are on the force and balance and unbalanced force. Let's see what is force. When you applied a force at anything that displays, it is known as force. Force can change. Okay, I write over here. Size, shape, dimension. Okay, that's not dimension, that is my mistake. Color, size, shape and color. Let's take an example. When you slap someone, the shape of his cheeks are flat. You have changed its size and also shape, and when you slap it, the area become red. So due to the force, you can change size, shape and color and anything that push or pull. Let's take an example. This is pen. I am pushing it, so I am applying force, and I am holding and pulling it backwards, so I am also applying force on it. So it is known as force. Anything that apply force on object, pull or push, it is known as force. Okay, so we have done force. What is balance force? When an object is when let's take an example. Person 1 and 2, also over here 1 and 2. So here the person 1 is applying 10 Newton of force on a brick, and person 2 is also applying 10 Newton of force on a brick. So brick will not move because net force is 0. 20 will cut out. Okay, both are applying equal amount of force, so the object will not move. The force of both the side is equal. It is known as balanced force. And what is unbalanced force? The force which is not equal from the both side, it is known as unbalanced force. Okay, so in example of unbalanced, person 1 was applying 30 Newton of force and person 2 was applying 20 Newton of force. So initially the person 1 is applying 10 Newton force more than the person 2. So the brick will move in the direction of first person, and net force is 10 Newton and the force is also not equal. Okay, from this example we found out that balance force is that both the sides are applying equal force on an object, and net force is 0, so it will balance force. And on one side the force is more and the second side the force is less, so the brick move towards in the more force, so there is force is not equal, so it is known as unbalanced force. Okay, you have to just remember balance here. Unbalanced means it is not balanced, it is unbalanced. Okay, so we have covered topic force, balance and unbalanced. So let's quickly see about what is inertia and first law and second law. Let's quickly see. So hello students, we are on laws of motion chapter number 8. We have done force, balance force and unbalanced force. Let's do inertia. So what is inertia? A mass of a body is measure of inertia. It means if the mass will more, the inertia will more. Okay, so you can take an example of train and car. Mass of the train is more and the mass of the car is less, so inertia of train will be more. You have seen that to apply a brake in train it very difficult because it mass was too large, so inertia will be too large. So that's why to take a train in a rest we have to apply lot of 1000 of newton of force is required, or maybe more force is required to stop the train. And while in a case of car, the car is not heavier than the train, so we have to apply less force to stop the car. Okay, so here I have written if mass is more, inertia is more. It means inertia is directly proportional to the mass. Inertia is directly proportional to the mass. Okay, inertia is directly proportional to the mass. Now let's quickly see about its definition. Tendency of object to remain in rest or in uniform motion until external unbalanced force is not applied. So this is the definition of inertia. Tendency of an object it the meaning of this sentence is a object, if it is in rest or in uniform, it will be continue in rest or in uniform motion until if you have not applied unbalanced force. Okay, let's take an example. Here a object is in rest. If you not apply force, it will not move. It means it will in rest, and if you apply unbalanced external force, it move in that direction. And let's take another example. Okay, this is car. Okay, a car is moving along a road. A car is moving along a road, and you are standing in front of it. Obviously you are not going to stop it because the mass of car and the mass of yours was very different. Okay, so we or car is moving with 0.5 meter per second speed on a 0.5 meter per second speed, so it will not harm the people. So the three people are needed. They will force oppose in the opposite direction. They will force on the car in the opposite direction, so the car will in the rest come into the rest. Okay, so this is an example of inertia. And let's take one more example. If there is 1 rupee coin, and when you throw on the surface of your house or any ground, and at a time you have to compare there, you have to also throw a 5 rupee coin. Okay, now see observe what is happening. You will found out that the 5 rupee coin will go more further. You have applied equal amount of force on the 1 rupee coin and the 5 rupee coin, but the mass of the 5 rupee coin is more than the 1 rupee coin, so it go more far away from the 1 rupee coin. So we have done the inertia, its definition and with its example. So let's move forward. Now we are going to do first and second law, and we will also see what is momentum. Second law is based on the momentum. Okay, so let's see. Hello guys, welcome back. This is I have made a notes to remember. Laws of motion have 3 laws. Okay, force and laws of motion have three laws which was given by Newton. First law, second law, and third law. Let's see what is known as first law. And first of all, I request you to pause the video and learn three laws. After this, we are going to directly do mathematically representation of second law, the examples of first, second, third law also. Okay, then we will see derivation of second law. Okay, we are not going to represent this definitions of first law, second law, third law on the screen. This is the last time. Okay, after this we are directly go on the examples and the derivation. So let's quickly see what is the first law. The first law and inertia both are equal, both are same, but in inertia the tendency word is used in the starting of the definition, but there is no word tendency is used. Okay, so to remain in rest, or this is the IMP word, rest, uniform motion until external unbalanced force act on it. Okay, these are the IMP. To remain in rest or uniform motion until external force is not applied, external force is not act on it. This is the first law. It means I have told that the inertia and this are the same. Once again, I explain you what is what is mean by first law. Is saying if any object is in rest, it will be in rest, and if any object are in continuing motion, it will be continue in the uniform motion until unless external unbalanced force is not applied in it. If the moving body is coming, I applied a external unbalanced force, it the object will stop over there, and any object was in rest and I will apply external unbalanced force, it will gain energy and continue in moving. Okay, so let's see second law. What is going second law? Rate of change of momentum. Rate of change of momentum of body is directly proportional to the applied unbalanced force. Rate of change of momentum is directly proportional to the applied unbalanced force. It means if you will increase if any object having mass and you are applying force and it come in acceleration, you will find the force. Okay, let's take an example of bicycle. You are applying a force on the pedal of the bicycle, and bicycle, if you are increasing the force on the pedal and the bicycle is increasing its speed, increasing its speeds, where however you slow down your legs, you slow down your legs, the bicycle automatically come in the rest due to the frictional force opposite in barabar. Okay, so second law. So rate of, remember this, rate of change of momentum of body is directly proportional to the applied unbalanced force. That means rate of change of momentum, if momentum is changing and momentum is increasing on the body, it is directly proportional. Means if the momentum of body increase, so the force will increase. If the momentum of body decrease, so the force will decrease. Okay, directly proportional to the applied unbalanced force. That means applied unbalanced force is more, so the momentum and the momentum will be more. Applied unbalanced force is less, momentum will be less. Okay, then both are directly proportional. So we have done also second law and as well as first law. So let's quickly see third law. Every action there is equal and opposite reaction on different bodies. What is saying by what is meaning of this sentence? I'll show. Here I punch on the board. That means I am applying pressure on the board with my fingers and the punch, but board is also applying pressure on my punch. Okay, so equal and opposite reaction is coming. If I am giving 10 Newton of force on the board will also give me 10 Newton of force. Okay, so let's take an example. Recoil of gun. When you fire a gun, okay, when you fire a gun, you move backward. Yeah, when you fire a gun, you move backward, and the ammo, the ammo of the gun or the bullet of the gun move forward, and the gun came backward. You have surprised that the mass of that bullet is 10 to 15 gram, and the mass of the gun is 15 to 20 kg. How it coming back, students? So remember the second law. What is it was saying? The force or a momentum will increase, so the it is directly proportional. So the force will increase, momentum will also increase, or momentum increase, force will increase. So the momentum of bullet is too high. Remember, students, formula of second law. We will derive it. Don't worry. We will derive it. This is the formula of second law. Remember this. We will apply it over here. First of all, you remember it. Don't worry. I am going to explain this law in the further video. Okay. So first of all, remember this. F is equal to ma. So m means mass and a means acceleration. So the acceleration, when you are firing a gun, a bullet came out of the gun with higher velocity, and it's changing direction. So it means acceleration with higher and higher velocity. So the mass is less, but acceleration is more. So when you multiply it, you will get more number of Newton forces applied on the bullet. So the acceleration is more. Okay, acceleration is more and the mass is less, but acceleration is more. That's why the bullet is going forward, and a lot of pressure is coming backward on the gun. The acceleration of gun is very less, and the mass of the gun is very high. That's why the momentum of gun is not too far. Okay, so that's why there is equal and opposite reaction on every action. On every action there is equal and opposite reaction on different bodies. That means two different bodies, the action will be doing of one body, and the reaction will be also done on the on the same body. It will not possible if the action was done by the one body. So the always reaction will be taken by the second body. Let's take one more example. You are throwing a tennis ball on the wall. You are throwing the tennis ball on the wall. Ball came towards you. It means the ball have forced the wall inside, and the wall has also forced the ball backside. That's why ball coming this side. Okay, here from here we know that every action there is equal and opposite. Equal, both are applying equal pressure, and opposite on two different bodies. So these are the first, second, and third law. I have said that we will do third law and the back end exercise in the last in the part 2, but I am thinking that the exercise should be in the part 2 and complete third law. Okay, so we have also done the third law. Now let's quickly see momentum and the formula of how to derive the second law. This formula, in this chapter there are only one formula, F is equal to ma. This is the most IMP. Students, this is the most IMP formula. I am giving surety that F is equal to ma will definitely ask in your exam. So while going in the exam center, please remember this derivation of the F is equal to ma, and its definition and its derivation. So let's quickly see what is momentum and how to derive this F is equal to ma in very easy way. Okay, so let's move forward. So hello guys, what is momentum? Let's see quickly about momentum. The SI unit of momentum. Okay, first of all, see momentum. Momentum is a product of mass and velocity. Product of mass and velocity. Okay, so momentum is denoted by P. Momentum is denoted by P, mass is denoted by M, and velocity is denoted by V. So momentum is product of mass into velocity. Its SI unit is kilogram meter per second. You can easily remember like this way. SI unit of mass is kg, and the SI unit of velocity is meter per second. And momentum cannot be destroyed. Okay, cannot be destroyed. It can be only create. It cannot be destroyed. It can be conserved or transfer. It can be conserved or transfer. It cannot be destroyed. It cannot be destroyed. It can only transfer. It can only transfer. So let's take an example. I am sitting. Okay, I am standing over here. Okay, I am standing over here. So I have mass. Let's suppose my mass is 50 kg. My mass is 50 kg, and I am just standing. I am not moving. So my movement, my velocity is 0. So my momentum will be 0. Okay, momentum is a product of mass into velocity. I having mass but not having velocity. So when my hand having 10 kg of mass and it move speedily, so it have definitely velocity of 10 meter per second. 10 into 10, 100 Newton momentum will be came out. Okay, so this is the example, and let's see how it can be conserved and how can be transferred. See, when you take this ball upward, okay, first of all I erase this whole thing. I hope that you have denoted this. You can write it fast. Write this and this example. Okay, pause the video and write it. Let's quickly see about the example. Okay, so I am taking up one ball and releasing from a height. It will gain velocity, and it has a mass also. So mass into velocity, it has momentum also. So it collide with this ball over here, transfer it momentum on this ball. This ball will also transfer its momentum on this ball, because the ball was no the ball was not getting sufficient momentum to move. The ball was not getting sufficient momentum, and also not getting space and sufficient moment to move. So this ball will also transfer momentum on this ball. So this ball having sufficient momentum also and space also. So it will go high and it will come back. So this ball will transfer momentum on this ball. This ball will transfer on this ball, and this ball will go up. Okay, so here the examples of momentum conservation, transfer of momentum. And as I have said that momentum cannot be destroyed, so you have think that it will continuously moving for whole life. You are right, friends, but when they collide at that point, over here, okay, when they collide, they convert into heat, sound, they give energy to air particle, etc. Their energy are converting into the heat, into the sound. They are giving the energy on the air particle, present here over here. when it collide, the air particle will move forward. By this way it lose the energy but cannot be destroyed. Okay, the energy of momentum is transferred into heat and sound but not destroyed. Okay, so let's quickly see about the derivation of second law. We have done first law, third law, second definition first law, second law, third law with their examples. We have done momentum, inertia, measure of inertia, then we have done balance force, unbalanced force, and force. Total 9 things we have done. So let's quickly, this is very easy chapter, just you have to pay attention. So let's quickly see the derivation of the second law. So students, let's quickly derive the question, second law of motion. Okay, so think about that. In football, one player passed me the ball. Okay, one player passed me the ball and ball is coming. Okay, ball is coming from this direction. Definitely it having the velocity and mass, so it will be a momentum. I was standing over here. I kicked the ball very fastly and gave it momentum. So I have applied a force on the ball and increasing its momentum. Okay, here the momentum also there, but less. Here also the momentum is there, but more. So I have exerted the force on the ball, but how can we know that how much of the force is applied by me on the ball? So momentum of ball before I have kicked and momentum of ball after I have kicked. Okay, we will see how much of the force I have exerted on the ball and increasing its momentum. Okay, so what is the, remember students, what is the definition of second law? Rate of change of momentum is directly proportional to the applied unbalanced force in a direction, in the force of direction. Okay, so rate of change of momentum, what is rate of change of momentum? I have said that if there rate of change of momentum it came, you have to just do the final minus initial. That means ball is coming, I have exerted force, so this is initial and this is final momentum. So if I want to find how much of the force and momentum applied by me on the ball, so final momentum minus initial momentum, what we denote momentum? P, pf minus pi. Okay, pf minus pi. So let's convert this into this. P means m, f means v, and p means m. Okay, sorry, m and I is u. So we will take m common, v minus u, and there is a word rate of change of momentum. Rate of change of, what is meant by rate of? If there is a word rate of, you have to just do the divide by it time. So v minus u upon t is equal to acceleration. V minus u upon t is acceleration. Okay, so we can write, and okay, this directly proportional. Okay, these are directly proportional. So f is equal to this converted into the a. Okay, so here the proportionality sign we have to remove first of all. So what we will do, we will add constant. The k is the constant. Okay, k is the constant, and it was experimentally verified that k, the value of k is 1. Let's see. The formula of this is equal to f is equal to kma. What they have done, 1 Newton of force 1 Newton of force is applied on 1 kg of mass, on an object having 1 kg of mass. So wait for a while. So force is 1 Newton and the acceleration they have produced is 1 meter per second. So if two things are value is 1, so k, they have found that the value of k is 1. Okay, so this formula is experimentally verified. You can write F is equal to ma. This we have derived the formula of second law. There is only one derivation in this chapter, so we have done whole chapter. So let's see what is impulse force. This is the impulse force is the last topic. Let's quickly see about it. So guys, what is impulse force? You have ever played the cricket in which a fielder was catching a ball? When, okay, let's see example. When the ball is coming from higher velocity and definitely it have it having a mass of 50 gram or 50 gram or 250 gram, so it coming with higher velocity, so you catch and not giving momentum, so you will get hurt. And the force is inversely proportional to the time. The force is inversely proportional to the time. It means the force will more if the force will more if the time is less, and the time is less, so the force will more. And time, okay, let's see. When the ball is coming higher velocity and you catch it, you are not giving it time. If the time is less, you are not giving time. If time is less, so force will more. And if time is more, then the force will less. Okay, let's see. When a ball is coming from here, I have catch over here, so I will get hurt because momentum is more, force will be more. I am not giving time that I have directly catch. I am not giving time, so I will get hurt. And if the ball is coming and I am giving time, so time is increasing, so momentum will slowly decrease, and the force will not at much higher, so you will not get hurt. Okay, from this we found out that force is inversely proportional to the time. That means force will more if time is less, force will less if time is more. So you can see in example, the player was catching a ball. Okay, the ball was coming from higher velocity and it catch over here, so it get hurt. And ball is coming from higher velocity, and thus you are giving the momentum, you are giving time to the ball, so you will not get hurt. So here we have also complete our topic impulse. So in this video we have covered whole chapter, and the exercises of this chapter we will do in the part 2. Okay, so we have done whole chapter and the all topics. So तब तक के लिए जय हिंद जय भारत.